Next slide. So I'm going to start by talking a bit about sort of my background and the lead up to my current job at Brandwatch. I did my degree in psychology and some final year neuroscience at King's College in London. I graduated in 2018, and I think, like a lot of people, during my degree was sort of where I started to realise what I was interested in and then what I'd want to pursue during my career. So when I was at uni, one of my main research projects was in genetics. So that involved a lot of genotyping, polymerase chain reactions, behavioural testing, all of that stuff. So it had the main element of that was a lot of data processing, a lot of data cleaning and analysis of that. And I also started using MATLAB to code and sort of program the behavioural testing element of that. So that's kind of where I got my first taste of programming. And then alongside my research project, I also did a few modules in neuroimaging. So again, started looking at MATLAB there as well to process neuroimaging scans and do the analysis on them with MATLAB. So I kind of got to the end of my degree, knew that they were the sort of things I was interested in, but didn't want to pursue anything in sort of the psychology, neuroscience or academia realm. So I started looking for jobs in data and tech in general. And then I came across the graduate data scientist position at Brandwatch, and it looked super interesting and was pretty much perfect for what I was hoping for. And I was really drawn to working as a data scientist at Brandwatch for two reasons. The first mainly being that Brandwatch has an amazing and a very strong culture. If you are familiar with Brandwatch, you will agree that they have an amazing culture that was really sort of pervasive through the job descriptions, all of the online content, and during the application process, you could see that it was just an amazing place to work. And during the interview process as well, and throughout my application, it sort of became apparent that the data science team were really keen to diversify, not even in the sense of like gender and age, but also to get people with different sorts of minds onto the team. So they were really open to hiring someone who didn't have a computer science background, which is where I fitted in. So then I moved from my graduate data scientist position to junior data scientist, and then up to being a fully fledged data scientist, which is where I am now. And that happened over the space of 2.5 years whilst I've been in this role. Still have a huge amount to learn. I definitely still feel pretty junior. I don't think that feeling will go away for quite a long time. I think it's quite common for this sort of career to be thought of as a marathon, not a sprint. But it's been pretty challenging at times, obviously learning to code in Python pretty much from scratch going into this, but it's been amazingly fulfilling as I've been doing so. So now on to gender diversity in tech. I wanted to present some statistics on sort of the state of gender diversity in the industry at the moment. I'm sure it's not going to be a shock to anyone hearing that women are massively underrepresented in tech. We represent only 27% of entry-level tech roles. This goes down even further to 15% of data scientists, and only 1 in 5 senior leadership positions are held by women. And recently I read a blog post where something in there was titled "Glimmer of Nope," and I thought that was quite funny and pretty fitting to the current state of gender diversity in tech, because these statistics aren't changing. They haven't changed since 2000. So we've had over 20 years of people and organisations making an effort to sort of increase gender diversity in tech. However, the statistics just aren't changing, and it just shows how much work there still is to be done. So I also want to talk about the reasons why we have such a huge underrepresentation of women in tech. And there's lots and lots of literature on this, but I wanted to present it in a way like this, in a sort of cyclical diagram, to see where the effects are and how they interact with each other. But I just want to say that everything that I'm going to mention here is from the literature. It's backed up by a huge amount of research. These aren't just sort of general musings from people in the industry who are hypothesizing the cases for this. These are all the output of research studies. So I'm sure it's not surprising to hear that the lack of representation of women sort of starts in the education system in the green bar. The attitudes and social norms that exist in our society massively impact the decisions that are made, even from sort of primary school age children and then starting to move up into secondary school children, where they're starting to choose their GCSEs and then their A levels. And I read some research recently where they were looking at the decisions made by girls of that age and in their decisions with choosing their GCSEs and A levels. And the output of that was that girls are particularly put off STEM and computer science subjects because they perceive the subjects as being incompatible with the ideas of femininity and sort of the social norms of femininity that exist. And also STEM subjects were perceived as lacking these sort of human-centered aspects that are really ingrained in our core value systems, being girls and women. And then this sort of feeds on to the degree gap, where only 18% of computer science graduates are women. So it starts in the education system, and then that feeds into a lack of women in the workplace, which contributes to discrimination in the workplace, which is the blue bar here. So the workplace culture gap is something that massively affects the lack of representation of women. So one statistic showed that over 50% of women in technology jobs say that they've experienced some form of gender discrimination whilst they've been at work, which I thought was firstly pretty shocking, and secondly really sad. And then we also have the pay gap playing a role here. The gender pay gap is probably the most sort of publicised gap of all of this content. And in tech jobs, even though tech is sort of considered one of the most progressive industries, we're still seeing a roughly, or on average, a 20% pay gap between men and women, where women earn 20% less than what men do. And I think a lot of people think that the answer to that is just getting lots of women into the industry through entry-level roles and training them up, etc. But whilst that is amazing, whilst that's amazing, it doesn't actually solve the gender pay gap, because then it increases the discrepancy between the wages of men and women, because you're having more women in lower paid jobs. So the focus really needs to be on the promotions that exist within the companies and hiring at a senior level and getting women up to senior level jobs. And then more recently in the literature, there is the pandemic gap, which shows how COVID has been disproportionately negatively affecting women. So women were more likely to be put on furlough at the start of the year, more likely to have experienced burnout, and also more likely to have experienced a drop or reduction in productivity due to childcare responsibilities. So we have the sort of picture of education going into discrimination in the workplace, which then feeds into having a lack of representation in the workplace. So as I said before, women just aren't represented in the senior leadership roles. Only 1/5 of these positions are held by women. And this also feeds into the retention gap. And there's quite a few sort of phrases that are spoken about in this retention gap. So the main one being the leaky pipeline, where when women who are qualified and do actually enter these jobs and secure jobs in tech, they end up leaving technology far more commonly than men leave technology. And this is also feeding into the idea of like a glass ceiling, where there is this sort of impenetrable wall between being entry level and mid level to being senior level. And then the lack of representation in the workplace then means that there is a lack of mentorship, a lack of role models in the field, which again feeds back and completes a sort of feedback loop here, where the attitudes and social norms are impacted by not having these mentors and not having these role models in the industry. So I also wanted to talk about some practical things that people can do to help and to be an ally for women in tech. I think these statistics are really commonly spoken about, and it's not a shock to anyone to hear them, but I think when these statistics are presented, especially online, the advice that follows them about what you can do to help is normally aimed at hiring managers. So what I mean by that is that the advice commonly talks about how to change job descriptions and how to reduce bias in your application process, etc. But I find that there's a lack of practical steps that people can take. If you're just sort of the average person at a company, you're not doing any hiring, and I found that people really want to be able to help. So I've summarised 3 things that, in my opinion, would be helpful for diversity in the field. So the first and probably the major thing is to engage with as much of this content and the literature surrounding gender diversity in tech as possible. So sort of acknowledging the statistics, researching the field within tech that you're in and seeing the state of gender diversity there. And also researching the state of gender diversity in the organisation that you're working for. A lot of companies do actually release their gender pay gap information, which is great, but also a lot of companies don't. So I think having these sorts of conversations, speaking about what's going wrong or what's going right in your company is really, really important. And lastly, with that point, training as well is crucial with this. There is so much content online surrounding training, and you can do unconscious bias training, and there is a lot of content that allows people to sort of acknowledge and highlight like where their biases potentially are. Then the second point is that something that would be really beneficial to the industry is people joining working groups and committees. At Brandwatch, we have a really amazing diversity and inclusion committee who solely focus on initiatives to improve things like gender diversity in tech. And I think there's a common misconception that only underrepresented groups should be joining these sorts of committees. And whilst that is important, it is nearly as important to have lots of different types of people in these committees and hearing about various people's experiences, even if they've not been underrepresented themselves. And then the third point here is something that's really important as well, is becoming an instructor or a mentor in technology. So I've chosen 3 organisations here: Code First Girls, the Girls Network and Code Bar. These all work towards helping people learn to code, learn to get into, or learn the skills that are necessary to get into a tech job. But they are often quite under-resourced in terms of having instructors and mentors. So I think applying to become a mentor or an instructor at something like this, an organisation like this, is really important. So, sorry, I skipped a few slides there. I just want to give some examples of things that I've done as maybe a bit of inspiration and some creativity to think of where your skills would be best placed. So I did a school outreach workshop a year and a bit ago, I think it was, at Cardinal Newman Catholic School, which is a secondary school based in Brighton. We did a full day of sort of introing what we do in our jobs and focusing on children who were about to choose their A-levels or GCSEs, and sort of allowing them to see that computer science is really fun and it's something that isn't just for boys to do. And I was also an instructor for the Code First Girls Python course, and more recently I was a panelist at the Future Software Developer Now programme, which was aimed at talking to a cohort who had recently completed the programme and speaking to them about the range of jobs that exist in the tech space. And for a sort of similar reason as well, I was also a panelist recently at the King's College London careers event at the department where I completed my degree. So speaking to people who are about to graduate or have recently graduated, and speaking about my job and sort of opening up the idea of moving into a career in data or tech, even if you've not done you haven't completed a degree in something directly related. And lastly, I'm also a mentor for a female student at the University of Sussex who's completing a master's in data science. So that's been a really good way to sort of boost her confidence and let her sort of have an insight into what it's like as a data scientist. So that concludes the first part of my talk, talking about gender diversity in tech. But the main focus of this session is going to be demoing my classifier evaluation tool. Sorry, I keep skipping ahead. So before I demo the tool itself, I think it's really important to intro Brandwatch and who we are as a business, and give a bit of context to where the tool that I've built sort of sits within that. So if you don't already know Brandwatch, we are a software as a service business in the digital consumer intelligence space. That's obviously a bit of a mouthful. So what that really means is that we build and sell a suite of products that facilitate querying, exploring, and augmenting online conversation. So our clients, who are typically brands, will use this online conversation, so things like Twitter, forum posts, Reddit, etc. They'll use this data, get insights from this data, and then those insights will go on to inform various different business decisions, for example. And the phrase that our CEO really likes is that we bring structure and meaning to the voices of billions of people. And then some features of the software that we sell. There are loads, but I've just chosen 4 here. So first one is sentiment analysis. So we have various models, one of which being the sentiment analysis model. We have emotion detection, entity recognition, and custom classification, where people can train their own custom models within the software itself. And this is where my tool comes into it. The rationale for building my tool was to improve the evaluation workflow of evaluating these custom classifiers. So what is the problem that my tool was trying to solve? The problem was that non-technical people have been needing to calculate performance metrics like precision, recall, and F1 when they're evaluating these classifiers. So we have a team of people at Brandwatch who work with clients who are using custom classifiers, and they therefore need a way to see how well they're performing, essentially. But this team, the people in this team typically don't code. They don't have access to any programming in their job. So as you can imagine, calculating things like precision, recall, and F1 is really hard to do manually. So we found that these people were calculating this in things like Excel and Google Sheets, which is pretty time consuming and laborious. But even though these calculations aren't particularly complicated, the ideas surrounding precision and recall are actually quite tricky to get your head around if you don't already have that sort of foundational knowledge of machine learning already. So I wanted to find a way that I could improve their workflow of this evaluation system that we're currently doing. And whilst the tool was more focused to what I just said there to help the non-technical people, it's actually still really beneficial to technical people too, who have even people who do have access to code and things like sklearn to generate these performance metrics. So I just wanted to give an example of a function that I wrote on the left, which is a function to create a crosstab heat map when evaluating a classifier. So as you can see, it's a pretty long function, pretty complicated, and I was finding I was doing that every time I was doing any sort of evaluation. And even if you go for something more straightforward, like this standard sklearn output, which is on the right here, whilst that is easy to generate, it still doesn't look great. So it's not something you'd particularly want to put in a report, and you almost do have to squint at it to see the most important numbers that sort of jump out in the output. So the solution to both of those problems was Dash. So I built a web application in Dash. If you haven't used Dash before, it's a Python framework for building web applications that are rendered in your browser. And I really like Dash because it sort of marries up Python and front-end languages, and it's really easy to write and read if you have a Python brain. And Dash is built on top of Flask and Plotly. So any sort of visualization that you can create in Plotly, you can really easily slot that into a Dash app. The syntax is pretty much the exact same. So if you've already got some code that is using Plotly, it's really easy to just do a few bits and then change that into a Dash app. And Dash has various different components that you use in your app. These are core components, Bootstrap, DAC, and HTML components. So that means that when you're building your app and building your layout, you're actually using HTML divs and other HTML elements. So it does feel really familiar in a web development front-endy way, but you're still writing pure Python. And then the interactivity from Dash apps comes from things called callbacks. Callbacks are essentially Python functions that have a dash components as input and dash components as output, but they only run when they're sort of activated by one of the input components changing. So I've included a really simple Dash callback graph here, where you can see how they sort of all relate to each other. The grey boxes are the components. So you can see over on the right hand side that an example is that if you change, say, a drop down component, the value that you click in the drop down can then feed into impacting your graph component. So before I go into showing the app itself, I just wanted to give some context to the data that I'm going to be uploading into the tool. So we have these are 3 rows from a larger sentiment data set. If you're not familiar with sentiment analysis, this is where you have some text and the classifier output is positive, neutral, or negative, depending on the sentiment of the text. So for example, here, I love everything Burt's Bees, but my favorite is the lightweight hooded sweater. So that's obviously a positive one, and that's what we want the output of the classifier to be. So the data that I'm going to upload into the tool has 3 additional columns. The first is the human label. So this is a label that a human has marked. So these are true or gold standard labels. And then we then have 2 classifiers. This isn't actually completely necessary for my tool. You can just have 1, but you can use 2. And I can show in a demo why that can be important. And then if you haven't done sort of machine learning evaluation before, the idea is that you compare the true labels in this column to the predictions from a classifier, and then that generates performance metrics, so you can get an idea of how well each of these classifiers are performing. Sorry, it's being really dodgy to move to the next slide. Okay, so accessing the tool, just going to switch tabs. Oh, sorry, I thought I'd missed a slide. That is confirmed that I have. Just going to present this one quickly. So this is talking a bit more about what my app does in terms of specifics. So it's a tool to evaluate machine learning classifiers by processing the uploaded label data. The label data comes from the human labels. As I said before, it improves the evaluation workflow that the team working with custom classifiers is currently doing. It provides an indication of classifier performance, and it does so by providing an interactive dashboard, various different performance metrics, and an opportunity for data exploration too. And the idea with this is that it sort of starts to answer questions like, are there changes that can be made in training? Do I need more data? And are these results what I was expecting? So now I'm going to go to the app itself. So this is what it looks like before any data has been uploaded. On the left-hand side is the control panel, and then the right-hand side is where the output is loaded once you've uploaded your data set. So the first thing you do is click this button to upload your data. So here I have the full data set, which is the full data set of the snippet I showed in the slides. And you click upload. It takes a few seconds, sometimes a bit slow as well when I'm on Zoom, but at this point, it's doing quite a few data validation steps, so checking that the file type is what it was expecting, checking that the types of the data are compatible with the app as well. So once it's loaded into the app, you then can select the columns in your data that relate to the text, true, and predicted columns. So here we have the text, had the text column label, the true label is the human label, and then the predicted label could be either the classifier 1 or classifier 2 that I showed in the data set, but I'm going to start with classifier 1. And the reason for choosing the column headers in this way is because it allows the app to be adaptable and flexible to whatever data you end up uploading. So we have a huge amount of data sets that are the outputs of classifiers. They're all of the columns are always called different things. So rather than editing your data before you upload to the app, you can select the columns this way instead. So choosing classify 1, and it does its thing. Here's the thing you're presented with is this summary tab. You have the total number of mentions displayed here and various performance metrics, so accuracy, macro precision, macro recall, macro F1, and a Cohen's kappa score. And we have these little tooltips as well where you can hover over them and see a bit of a summary about how the performance metric was calculated. So that could be quite good to sort of jog your memory if you're having a mind blank about it. That's not coming off for some reason. And then we have the category imbalances graph. So on the y-axis, we have the number of mentions, and then the x-axis is the different classes that exist in your data set. And then the different bars just show the number of mentions that have been labeled or predicted as that class. And this is also flexible too. So depending on the data you upload, the categories on the x-axis will relate to the categories in your data set, because of course, classifiers aren't always sentiment classifiers. We have in our app at the moment, we have emotion classifiers. So if that data set was uploaded here, you'd see happy, sad, anger, etc. So it's another way that it's adaptable to data. What I find most useful when doing the classifier evaluation with this graph in particular is that you can see really quickly and easily if you're getting one category or class that's being over predicted. So in some data sets, I've seen one class be like the blue, which is the predicted value, be huge, and the green bar would be really low, and that's showing that something's going wrong there with the prediction, or something going wrong with your model where it's over predicting a particular class. So now moving on to the classification reports. These are broken down by the overall averages and then the per class or category averages. So on the left-hand side, I wanted to provide some more performance metrics beyond just the macro averages that I was presenting in this summary tab. So you have the accuracy, macro, weighted, and micro averages, and these are presented in a Plotly graph. So this is what I was explaining before, where because Dash is built on top of Plotly, it's really easy to just slot these graphs straight in. So this Plotly graph should be familiar in terms of like the toolbar here is exactly the same as if you were generating it in a notebook. Then on the right-hand side, we have the per category performance metrics are broken down by the positive, neutral, and negative classes. Again, this would be different if you had different classes in your data and then presented in a graph structure too. You can also export various different components. So here you can just click the export button and then it will download for you. I won't open that, but that can be quite a good way to save that and then do other calculations on those if you need to quickly export something rather than just noting down the numbers. So then the third tab, I have two different confusion matrices. The first one is a sort of more common crosstab. This is presenting the raw numbers of the predictions by the model and the labels by the human, and you can see that on the diagonal these labels are green because these numbers are where the classifier has got it right. So here for 93, that shows that 93 pieces of text have been labelled as being positive and also predicted as being positive. So that's great. So we want the numbers on the diagonal to be as high as possible and then the numbers off the diagonal to be as low as possible. And whilst it is good to see these numbers in a raw sense and sort of get an idea of how many predictions there are per class. It's also good to see it in a normalized heat map. So this is the exact same data that I was presenting above. However, this time it's normalized across the rows, so they become percentages. And this is useful if you have different numbers in your numbers of mentions or text in your classes. So it's easier to see as a percentage. It's far easier for it to sort of jump out exactly where it's going wrong. And this is also color gradiented as well. So the opacity of the green and red sort of shows how good or how bad that number is. So if we're looking again at the positive class, those that have been labeled by human as being positive, it's easier now to see that a lot of these 59% are being predicted as neutral. So again, both have their values in terms of classifier evaluation, but typically the normalized heat map is a bit easier to see exactly where's going wrong or where's going right. So now on to the Explore Mentions tab. This is a space to really dig into the data and have a look at the text in your data set. I'm just going to move my Zoom window. So you can see all of the different pieces of text, and then their true label, their predicted label, and then also if the classification by the model is correct or not. Then you can use this space to search the data set. So you can type in a keyword and it will filter the data set to that keyword. You can also filter by whether the prediction is correct or incorrect, and then the true and predicted classes here. So I can show that here. We just look at incorrect, should filter, again being a bit slow. I promise you have to take my word for it that it does work. And then we can click this filter by associated words button too. This is probably my favorite part of the app actually, and what I found most useful. Here it shows the words that are most associated with each of your classes. So for negative, it sort of really does make sense of seeing words like boycott, hell, WTF, etc. Then for positive, seeing words like perfect, fantastic, awesome, and then neutral words are typically not sentiment bearing, which is what we can see here. And you can also use this to show or to increase or decrease the number of words. And to generate this is not particularly complicated maths, it's just a simple probability ratio which displays the words that are disproportionately associated with each of the classes in comparison to the background full data set. And this is useful to not only sort of eyeball and sanity check that this is what you're expecting, but it also can be a good way to reveal any bias that's happening in your data. So if you're getting words that are being associated with the negative class that are sort of screaming out being sort of a bias, then you can then filter there and seeing if you need to sort out or reevaluate your sort of training steps. So in one of the data sets, it was easy to see some potential bias that wasn't actually biased. So the word daughter was being associated negatively, but when you filtered the mentions to the words that contained daughter, it was just because there was a lot of bad press surrounding the daughter of a politician. So you can, even if it appears to be a bias, you can then go and check the data and confirm whether it's serious or not, essentially. So the final tab I'm going to talk through is this comparison tab, and in this space you can compare different classifiers to each other. So if you remember here, when I selected the column labels, we had the classifier 1 and classifier 2. You can select this classifier here and it will quickly calculate the performance metrics, so you can get an idea of the comparison between both of those models. And this isn't sort of a necessary step of classifier evaluation, but it can be quite useful if you have two different models running over the same data set and you want to see which one's performing better. Or there's been quite a few cases where you train a classifier, run it through here, but then you go back and retrain, and you want to see whether your retraining has resulted in any improvements. You can click as many of these as you want if you have multiple classifiers. And then the final feature that I want to show is the Learn More button up here, where you can click that and it renders a markdown pop-up, and you can see lots of information about these performance metrics, so precision and recall, and a bit about what they mean, but also how they're calculated, and a diagram here sort of for the more visual people. This particularly helped me when I was learning the concepts of performance metrics. And again, just lots more information about these various metrics. I wanted to add this because a lot of people who would be coming to the tool, as I said before, might not necessarily have a background with building machine learning models. So this could be quite a good way to educate yourself on the output of this app, or to sort of refresh your memory about what these performance metrics actually mean. So in terms of things that are happening behind the scenes, I used Flask caching with this app because in some cases the data sets that are being read in are huge, and because there are a lot of components that are all accessing that data, I found that it was becoming super slow, really inefficient if the data was being read each time during those callbacks, or even if it was being held in one of the store components, it was still making it really slow. So I implemented Flask caching, which essentially means that the data set is read in once and it's cached, and then the callbacks access the cache rather than reading in the data every time, and that really hugely sped it up. And then finally, in terms of deployment, the deployment side of things was actually handled by one of my other colleagues on the data science team. They have built and created this website and server that hosts all of the different web apps that the data science team make. And the way you get your app to the website is by pushing to a particular GitHub repo, and once you merge your PR, we have a continuous integration system set up by Jenkins, which is facilitated by Jenkins, that can build the Docker container for that app, and then it sets the app up on the server. But because everything is on that website, this does mean that this app is only internally accessible to people who work at Brandwatch, which means that I can't share a link to anyone, unfortunately, after this talk, and I also can't show the code, but I'm happy to answer any questions sort of surrounding the building of this and the setup. So just going to go back to my slides for a bit of a summary. So just to sort of conclude the second part of my talk, the rationale for building the app was to improve the workflow of evaluating these classifiers, because manually evaluating them by this team who used custom classifiers was really laborious and intensive. And this tool sort of provided a fairly quick and easy solution to show a sort of quick and sleek way of evaluating these custom classifiers without having too much faff in spreadsheets, etc. And some of the features that I've discussed are the data validation steps, adaptivity to uploaded data sets, on-the-fly performance metric generation, the Flask caching of the data sets as well, the associated words feature, model comparison, and the performance metric education. So that's everything from me, I think. I'm now happy to go into a Q&A part of this, but if you've got any comments, questions or suggestions after the talk, or just want to connect in general, then definitely find me on LinkedIn. My email is crsharp@brandwatch.com, and my Slack on the data forum Slack workspace is @Russel-Sharp. Thank you very much for listening, and look forward to any questions that people have.